This construction report focuses on the processes and procedures in constructing the substructure of the Northeastern Specialist Healthcare Centre commercial building located on North East Road, being under construction by the company Batch. Work had commenced 4th of April 2017 with the practical completion date roughly at the end of 2018. The substructure is the structural foundation of the building, which in turn transfers the loads to the ground or below the ground. Activities involved in the substructure construction process include site investigation, site clearance and demolition, excavation, steel reinforcement, concrete pouring, and curing of the slab. Within these, there are small sub-branches. Before the site is cleared, preliminary site investigation is required to ensure a safe and economical design, including soil samples. The engineers thus have the information to design the foundations and footings accordingly. Demolition of previous structures on the site is the initial stage of the construction process. The site for construction had existing buildings, which needed to be removed before the site could be prepared for cut and fill and foundations. The site spanned over multiple pre-existing blocks of land, including blocks with houses, sheds, and buildings. A temporary hoarding or site boundary was established before the demolition due to the location and nature of the site. After the main demolition of the structural buildings and disposal of waste, the site then needed to be cleared and prepared for construction. This involves the removal of smaller debris, plants, and trees. It then needs to be filled and flattened, ready for works to continue. Bobcats, rollers, and excavators are brought in to distribute the soil and flatten or compact it. The soil is brought in using trucks, which is then tipped. Once the site has been cleared and compacted correctly, the excavation can begin. The site's footing system consists of broad piers interlocked with a raft slab. What this means is that every corner of a footing there will be a broad pier. A broad pier is a concrete cylinder that sits in the foundation to add structural support. The broad piers allow a deeper footing to compensate for a highly unstable soil. A piling rig then drills into the foundation of the site. Once the broad pier has been drilled, the steel reinforcement cages can be placed inside them. Steel is added to increase the tensile strength of the broad piers. Concrete is poured directly from the concrete mixer on the back of the truck in the broad pier. A vibrator is then used as the concrete is being poured to rid any air bubbles. The concrete is then covered in sand until it reaches the ground level, as seen here. Situated in the middle of the site was the lift pit. The lift pit had been dug out under the foundation level using an excavator. 4 broad piers were then installed following the same process as mentioned before. A dam-proof membrane is then placed over the pit, with exception of the broad piers, to prevent any water entering the structure. Concrete is then poured and screeded. The concrete pour is to create a bond between the concrete and broad piers, allowing a strong base to be created. Steel reinforcement is added, starting with the bottom square mesh. Steel reinforcement walls are then erected on each side. The steel is tied down manually. This is done by tradesmen using pliers and is tied every 3 intersections. Formwork made out of wood is then added in preparation for the concrete pour. Steel is also used in the inside of the shaft to add structural strength. After the concrete has been poured, the panels can be stripped away and used for the continuity of the shaft. The foundation is dug out using an excavator following the engineer's plans. In this particular case, the trenches were battered and benched for safety reasons. After the excavation is complete, underfloor plumbing services are fixed. These pipes will all run into the public sewage pipelines on the street, which in this case is located on Paula Avenue. Steel reinforcement is then added to the foundation, which increases the tensile strength of the concrete. It is important when placing the steel that there will be enough covering of concrete so that it is not exposed. If unprotected by the concrete, it may begin to rust with the presence of water and air. This will cause its strength to decrease and lead to spalling of the concrete, which in turn will affect the structural integrity of the slab. Since the slab is over 20 meters in length, 2 layers of mesh are used to increase the strength. Chairs are used in between the 2 layers of reinforcement to ensure correct concrete covering and also help hold it together. Before the concrete can be poured, formwork must be added. Wooden formwork that will be supporting the concrete when it's being poured can be seen in the above figure. Chairs holding the slab mesh in place are also evident. When mixing the concrete, the person must take into considerations such as workability, loads that need to be supported, environmental conditions, and surface wear. Once the concrete has been mixed in, it can be delivered to the site on the back of a truck in a concrete mixer. A vibrator is then used to expel any air bubbles that may be formed within the concrete, meaning it is crucial the spacing of the reinforcement allows access for the vibrator. Next is screeding, which involves a large piece of wood being pushed over the concrete to create an aesthetically pleasing look. A helicopter, as seen here, is then used to trowel concrete, further compacting it and adding the smooth finish. The last step of the process is curing, involving the concrete to set so that it can achieve its optimal strength. It is important throughout the curing time that the concrete is supported by formwork and kept hydrated. As seen throughout the report, the substructure is a time-consuming and sometimes complex part of the construction process. It is also an extremely important aspect, as without a strong foundation, the structural integrity of the building may fail. Once the substructure has been completed, the process continues with the construction of the superstructure.